When we're working with the circumcenter, here's a few things, the reason why we have the name for it. And this is one of those interesting pieces of information that later makes more of a difference than right now. When you draw a triangle, remember we talked about inscribed and circumscribed. Circumscribed means you touch every vertex on the outside. So if I would draw around a triangle this circle that intersects every one of its vertices, what we notice is if I draw in the perpendicular bisectors, notice where it hits. Smack dab the center of the circle. So we know that when we have the circumcenter, okay, it contains all the vertices of the polygon that is circumscribed about the polygon. So that's where circumcenter and circumscribed, their relationship between the two. Now, here's the examples that we're going to do. And guys, if you draw this, it's going to be much easier for you to understand. Okay? If you had to strictly draw this, you'd always get this. And this, we're only doing this, and everyone please hear me on this. We're only going to use circumcenters of right triangles. All right? So that means they're going to intersect on the hypotenuse. Now, let's flip back for a second. Where on the hypotenuse are they always going to intersect? The midpoint. So I need to know the midpoint of the hypotenuse of my right triangle. So the first thing they do is they say find the circumcenter of triangle HJK with the vertices. So notice I went ahead and I graphed this triangle. Now if I was to do the perpendicular bisectors, we could very easily see how this is being formed. Well, look at the perpendicular bisector here and my perpendicular bisector here, because remember halfway between 6 is 3, halfway between 10 and 0 is 5. Notice where they hit, the midpoint. Now the cool thing is I don't have to graph it to learn it because we know the midpoint. The reason why we graph it is just so we know the endpoints of the hypotenuse. And that in this case is going to be K, which is at 0, 6, and it's going to be at J, which is at 10, 0. So now I can actually do the midpoint of the hypotenuse. Again, this is the only type that we're going to do. Now remember, how do we do the midpoint formula? That's x1 plus x2 over 2, y1 plus y2 over 2. So it's the average of my x's, so 10 plus 0 over 2, and it's the average of my y's, 6 plus 0 over 2. That's 5, 3. Look where my midpoint is, 5, 3. Not bad. Now let's do the same thing here. Notice I'm not going to do a big formal graph like this one, but I do want to know the center of the circle that you can circumscribe about the triangle with the vertices. What does that mean? Find the circumcenter. Please understand you're going to refer to your notes for this. So I'm going to regraph this real quick. Okay, shouldn't have done that right there. We'll do it right here. Here's x. There's y. Now, let's graph this triangle. We have 0, 6, so it's up here somewhere, is 0, 6. We have a negative 8, 0. I'm going backwards, I'm not sure why. Negative 8, 0, so I go over here to negative 8, 0, and I have the point 0, 0. Now, if I put those points together, which one are is my hypotenuse? Right there is my hypotenuse. So where's the circumcenter going to hit? Well, the circumcenter is going to hit at the midpoint of my hypotenuse because that's where the perpendicular bisectors will intersect. So remember, the midpoint of the hypotenuse is the following. A negative 8, notice I don't have to use the 0, 0, plus 0 over 2 with 0 plus 6 over 2. That's going to be a negative 4, 3. So it's going to be the midpoint of the hypotenuse is the center of the circumscribed circle. Now notice that means I'm doing a circle that looks something like this. I'm not having to draw that out because I know where it's going to be located. Now let's do the same thing. It says find the center of the circle that circumscribes about the triangle with the vertices. What is that? The circumcenter is the center of the circumscribed circle. So that means find the what? The circumcenter. Oops, let me show it up there so you can see it. So again, don't you think I'm going to go ahead and graph this so I know where the hypotenuse is? So quickly, I don't need a formal graph. I just need to give a visual idea so I learn the hypotenuse. So one of those is 1, 7. 1, 2, 3, 4, 5, 6, 7. All right. So there's 1, 7. And the other point is at 1, 1. There's 1, 1. The other point over here is at 5, 1. So when you have those, it should look like this. Now, where's your hypotenuse? My hypotenuse is the longest side. So if I go up, and this is a distance of 6, I go up 3, 1, 2, 3. If I drew in my perpendicular bisectors, it should be landing about right there. So there's my circumcenter. I need to use my midpoint of the hypotenuse. Some of you don't even need to do this. As long as you have this, you're like, ooh, midpoint, I don't need to give the visual. I know I'm looking for the midpoint of this. So my 2 points I'm going to use is 1, 7 and 5, 1. And I'm just going to write this again to remind you. That also means center of circumscribed circle. So no, that's what it works. So let's do this real quick. The midpoint of 1, 7, and 5, 1. So those are the 2 points. So we have 1 plus 5 over 2, and we have 7 plus 1 over 2. So what do we get there? 6 divided by 2 is 3. 7 plus 1 is 8, is 4. And you know what? That's about right. 3, 4. Hopefully that helps us figure out where the circumcenter, or the center of the circumscribed circle, is going to be located.